Hello everyone, how's it going? For the next video, I'm going to solve the number of islands problem. This is one of the most asked problem in Amazon. It is it is a medium level problem that is tagged on LeetCode. Um, it is tagged under BFS and DFS as well. I think. Let's take a look. Related topics. Yeah. So depth first search and breadth first search. Um, and the question stem says, given a 2D grid of map, ones which are land and zeros which is water, count the number of island. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So what this means is, let's say in this particular grid we have all these ones, and all these ones are connected either horizontally or vertically, and that's why they form an island. There are no other ones which are not connected to this particular group of ones. In the second case, we see that there are this we see that there are these four ones which are kind of secluded from this particular one, and then there are these two ones. So we cannot count an island in a diagonal fashion, and that's why we have one group of ones. This is the second group of one, and this is the third group of ones. We have three islands. Anytime we have a grid, the most straightforward way to explore a grid is by using a breadth first search. And what we'll basically do is we'll start from any of the ones in the grid, and from there we'll try to explore like which are the other indexes that we can jump from over there. And when we run out of the ones which are directly connected to it, we will move on to the second item, and so on. So in this case, like we'll start from over here, and then we can jump to this one, from there to over here, and there to over here. Now since from this particular one we cannot jump to any other indexes which are one and which are not already seen. Let's say so we can increment a count, and we can say that we have seen one island. Then we move on to the next particular island, or just one, and so on. I know it sounds slightly complicated, but I also hope that once you go through the code, it becomes simpler. So let's see. So first, we'll start with some basics validations. So m is equal to length of grid. If not m return 0, we do need a grid too in order to process anything. Uh, my bad, sorry. And if not n return 0. So we do need at least one row in the matrix. What we'll do next is we'll just record all the ones that are there. Now, we don't need to do this. There are like a lot of improvisations, but I find it easy when we like write down each and every one step. So what we'll do is we will mark the index of each and every one in the grid. So this is like O of n square loop. So for I in range m, for j in range n, if grid x y equals to 1. And I think this is a string, so we'll need to do this. Anyways, what this line means is we will go through I in range m, so we'll go through the rows, and for j in range n, we'll move vertically as well. So for each and every x and y coordinate, we will see if it matches 1, and if it does, then we'll just um, we'll just write those x and y indexes in this dictionary, or aside, yeah. The next thing we'll do is we need a variable in order to count the number of islands. So we'll start with an assumption that we don't have any islands in the grid. So that's why we have count 0. Now we need to create a loop that will go through each and every one of the ones, and unless we keep on finding x and y coordinates, we'll just keep iterating. Mhm. So Q. Um, so what you want to do is you want to start with this first index. So what we can just pop the first item from the ones. So collections dot tag and ones dot pop. So this will so the Q will have two values, the X and Y. And what we'll do is while there are elements in Q, so while Q, what we'll do is Q. So we want to extract those information of those two variables. So P comma Q is equal to Q, and I know this is like Q is they sound very same. Oops, it's pop left. So and the reason and it doesn't really matter whether you do pop left or just simple pop. If you do pop left, it means you're doing an BFS or breadth-first search. If you're doing just pop, so you're removing from the right hand side of the queue. So if this is like a sort of queue 1, 2, 3, pop left will just remove the element from this index. Pop will remove the element from this side. Anyways, so now we have x and y coordinate of the first one that we have in the grid. What we want to do is we want to explore the um, the rest of the ones that are connected to this particular well x and y coordinate. And what we can do is we can just jump from over there. So we'll see where all can we jump. So there are like 4 directions in which we can jump from any particular position in a grid. It is either horizontally or vertically. So up, down, left or right, up, left or right. So for x comma y in mm, p plus 1 q, and very soon like you will see that this is like very standard way, and if you want to ever explore a grid, p minus 1 q, p comma q plus 1, p comma q minus 1. So this is like this is just saying that we want to go up and down, and then there are like few edge cases that we'll have to see. Like for example, if we are over here, then we cannot go up or we cannot go left. So we want to make sure that we always stay within the grid boundaries. So if 0 is less than equal to x is less than equals to m, and 0 is less than equals to y is less than n. So we always wants to stay within the grid. And we also want to know that the current element that we see is actually a 1, and we don't want to explore a 0 because that's water. So grid xy in ones, or rather, my bad, x comma y in ones. So we already have marked all the ones that we see. Uh, so what do we do now? So if we see that, hey, this is a 1, what we want to do is we want to append the one. So we actually want to jump from uh, one element to the other one. So we want to append it to our current queue. So we will append it. And what do we append? So we want to append that x and y. And then we don't want to visit the same element again. So we don't want to visit this, like we have already seen it. So we will remove it from the main queue that we have, or the main set that we have of ones. So we'll remove that from over there. Okay. And once we have done that, we will, so once we have explored each and every one that is connected to a particular land that we started with, we can mark that, hey, we explored all the ones that are connected to it, and so we can increment our count to by one. So we have explored like one island, and once we do that, at the end, like it will just explode the entire grid, and at the end we just return the count. So let's see if this works. Fingers crossed. Oh no. Free variable x reference before its assignment. Well. What do we have over here? Ah, I see. Because and these are not x and y. These are I and j. Let's see. Okay. Um, so this one works. Let's try to submit. Hopefully this works. Okay. So this one works. We see that it ran in 152 milliseconds. Sometimes I've seen that the runtime is slightly less for Python as compared to Java, but that's just the containers that LeetCode is running on. Do let me know if you see any improvisations on that. Please like, comment, subscribe. Let me know if there are other problems that you would like me to solve. And for the next time, thank you.